Hello, I am Dr. Zakir Hussain. Today I am going to show you the experiment. This experimental setup is located at Unit Operation Lab 2, Building 27, Room 105. Let us go inside of this lab and see the experimental setup. So, we maintain lab safety perfectly in this lab. As you can see on this entrance door, some important information are given. The emergency number, you can see the emergency number here. You can see the laboratory safety instruction poster hanging on the wall. You can see here first aid kit, fire blanket, safety guidelines for lab users, some personal protective equipment, for example mask, gloves, goggles, helmet are located in this cabinet. Students are not allowed to work in the lab without personal protective equipment. This is safety corner. You can see emergency eye wash station. You can see the emergency shower as well. There is a fire extinguisher here. There is a fume hood here. It is used for all chemical handling. So, there is a big hall room here. A number of instruments are placed here. We also maintain lab safety perfectly in this lab. This is gases mass transfer and diffusion coefficient determination unit. It is used to investigate the diffusion of a volatile liquid in a stagnant gas. It also allows to investigate temperature influence on the diffusivity. Let us see every part of this apparatus. So, you can see water bath. It is filled with water. You can maintain any temperature of this water using thermostat. So, we are maintaining here 35 degree centigrade. It is a small diameter tube. As you can see, we fill up half of this tube by a chemical acetone and another half is empty, that is fill up with air. You have to use fume hood when you fill up this tube by acetone. So, this is a fume hood, and for all chemical handling you have to use this fume hood. Our chemical is acetone. So, we move a little bit acetone to a beaker. From a container. Then you can use a syringe to transfer acetone into the capillary. So, this is our capillary and you have to add half, you have to fill up acetone half of this capillary, okay, using this syringe. So, to remove air bubbles, so you can just do like this, shake several times like this way, and then we need to return it back. So, you can fill up the capillaries around half of this height using this the same way. After this, capillary tube is placed inside the water bath. Since water bath is maintaining with certain temperature, so you can assume acetone temperature is same as water bath. You can see air blower, it helps to blow the air on the top of the capillary tube. So, the idea is acetone is slowly evaporate, and when it reaches to the top of the capillary, then it is washed away by blowing air. So, the concentration of acetone at the top of the capillary is 0, and concentration maximum at the acetone air interface in the capillary. There is a vernier scale inside the water bath. As you can see, capillary tube is attached on this scale. So, you can measure the level of acetone. So, your job is to find the empty space height with different time. Since it is slow process, every day you have to take data height versus time twice, one at morning and another one at afternoon. You have to continue this experiment until this whole week to get sufficient data set for calculations. These data sets are for one temperature. So, another group will do the same with different temperature, and they have to share their data set among groups. If you have two data sets, separate data sets for two different temperature, you can calculate easily the effect of temperature on diffusivity. Overall, the objectives of these experiments are determination of binary diffusivities of volatile organic in stagnant gas. Our organic solvent is acetone here. Then the second one, comparison between the experimental and predicted values using Lennard zone and Fuller correlations. So, you have to compare your experimental data with the theoretical correlations. Study the temperature influence on the diffusivity, that is the third one. The fourth one is determination of molar flux, and the fifth objective is graphical representation of the concentration profile for acetone and air. You can explore the theory behind this experiment and calculation in the PowerPoint, which is available in the blackboard. This is emergency exit door of this lab. I have done the experiment and I am going out from this lab. Bye bye, see you next time.